Here we have xy plane, and let's say here is L and here is minus L. We have a charge of Q at these 2 points. Now we have to find out the function of y for the electric field at this along this y axis. Now let's say we have this point, and from here you can see this is R, and this will produce electric field in this part, and we have another charge to produce electric field at this part. So you can see this x component will get cancelled out. The only remaining is the y component. So now I'm going to define this data here. Now electric field is given by 2q because we have two charge for pi epsilon r square, and you can see the separation distance is the same for both charge until that point. So now this is a sine data. Sine data will give us this y component. So this from here to the origin, this is given by length L, and from here to here, let's say this is given by y. So r is given by square root L square plus y square. And now sine data given by the opposite, this is y over the hypotenuse. This is r, y square plus y square 3 over 2. And I think this is the answer for A. Now for B, you want us to show this the field is a maximum and y equals this thing. So as you all know, to find out the maximum or minimum, we always use the differentiate and make this differentiation will be equals to 0, and we can find out the point. And this is clearly we use differentiate with respect to y because we want to find out the point in this along the y-axis to give us the maximum electric field. So by here you can see we have one y here and one y here. That means we have to use the product rule. First thing, we deal with this y, this will be the for pi epsilon, and the rest should be the same. And now for the second part of this product rule, we are going to deal with the y at the denominator. So this is a 2qy, this is a 4 pi epsilon, and this is L square plus y square 5 over 2. And you can see this denominator, this part actually is given by this L square plus y square minus 3 over 2, right? When we do a differentiation, so this 3 minus 2 left to minus 1, we get a minus 5 over 2, which the thing we get here. And now for this thing, we remember to just give us this minus 3 over 2, and you can see this y is in the bracket of this thing, so we have to differentiate again inside. This gives us 2y. Now this whole thing should be equals to 0 because we want to find out the maximum point. So to Q find this one square 3 over 2 and equals to. Now continue from here. You can see this 2q can be cancelled out. 2q can be cancelled out. This 4 pi epsilon can be cancelled out. 4 pi epsilon can be cancelled out. And this is the remaining is 3y squared and l squared plus y squared 5 over 2, and this is 1 over l squared plus y squared and 3 over 2. Now 5 over 2 over 2, this is 3y squared, and you can see actually this part is just equals to 5 over 2 minus 3 over 2. This whole thing is good. 3y squared, and from here 5 minus 2 minus 3 over 2 give us a 1. So that means this is equal to this l squared plus y squared equals to 3y squared, and l squared is given by 2y squared, so uh, y squared is given by l squared per 2, and y is given by this l per square root of 2. And of course, because the this is a square here, we have to put a plus minus sign. They have two possibility, can be plus, can be minus. You will get this